This is the third video for the 7-1D lesson. So you attempted to compare, hopefully successfully, or you can make some adjustments, side length of a square in the perimeter. This was a square, not a rectangle, but a square, um, such that if the side length was 1, that the perimeter was 4, because 4 sides, each at 1 apiece, is a total of 4 for the perimeter. I would encourage you to pause the video right now and try to answer the next couple of slides. But I would also maybe watch this video to make sure you understand what these questions are stating, because they could be somehow misinterpreted. So the first question is this a function? Explain your reasoning. Sorry, is this a linear function, or is this function linear? Explain your reasoning using the graph. Well, it does pass muster for being a linear function. First of all, it is a line, just like we've come to know. In fact, this is a line from Module 2 or even 7th grade. And it is a function because it's going to pass the vertical line test. Each input's paired with exactly one output. Yes, this function is linear based on the graph because um, it is a line and has a constant rate of change was one of the requirements of it being a line. But this is kind of a goofy question because if you just look at the graph, um, you know, looks like, smells like, feels like it's a line. Next one says, is this function linear based on the table of values? Well, the answer has to be the same, but maybe our justification is going to be a little bit different. Um, And yes, this function is linear based on the table of values because there is a constant first difference of, this goes up by 4 and up by 1. So this is of 4. And then next one, is this function linear? Explain your reasoning using this equation. And we'll say yes. Yes, this function is linear based on the equation because it is in the form y equals mx plus b, which is known as slope intercept form. Also, maybe an important note just to think about that was somewhat glossed over, which is that this is a function because each input is paired with exactly one output, right? That we could easily take that for granted, but that by saying, is this function linear, we should think about, first of all, is it a function? And then secondly, is it in fact linear? And it actually is both for this example.